Hello friends, I am Neeraj. In this session, we will talk about interface as a type. In past few sessions, we already talked about interfaces and we have fair much of understanding about interfaces, what interfaces are and how we can use it. So if you haven't watched that session, so I would provide the link in the description so you can have a look at them. And we know that we know that very well that Go doesn't have any explicit implements keyword. So in order to implement the interface, rather Go has a implicit implementation of interface. So when we say about implicit implementation, so that means that whatever function that interface is going to have. So for example, say here we created an interface worker having a function do work, and whichever struct, whichever type, if that type is going to have the same do work function with the same function signature, so that would be said that this struct or this type is a type of worker interface as well, because this has the same function signature of as the function signature defined in the worker interface. Simple. So this we already have talked about. So but in Go, so actually we can define an interface like this: interface name with the keyword interface with an empty interface also. So just the name of the interface, or just the interface without any function, but without any function signature. So this would be called as an empty interface, and Go already provides a empty interface. So that is what we are going to see just right away. So for example, say if we need to create a variable of type string, so we can write it something like this and like this. So here we are saying that with the var keyword we are creating a variable whose name would be str. The type of this variable would be a string and the value would be Neeraj. Okay. So but we can also write, let's say we will write it istr instead of the keyword type string. We can say something like this and we will assign the value here. And if we try to print this like this, so we will go with printf, so that we can also print the type of the value as well, type of this variable as well. So we will say this is str and this would be our istr, interface str actually. So by istr I am meaning that this is a str with a interface str. You can name it, it is just a variable, so we can name it anything, %t and %v. Here we will provide str and again str, and that would be a second variable like this. So now let us try to run our program. Go run main.go. So here we are getting also, so let me add a /n for a new line character. Let me clear it. So here we are getting for the variable str, the type of this is a string and the value is Neeraj, and for the second variable istr which we defined as a type of interface, so again that type is again the string and the value is Neeraj. So this is happening because every type implements a empty interface, because this is an empty interface. It is an interface without having any function signature, and this is why like every type automatically implements a empty interface. So this is how we can use it. And however the concept is clear, but the best purpose of this concept would be when we define a function. So let us say we are going to have a function that displays something, and this function is going to accept argument of type, let's say string, and this is not going to return anything, and it is going to, we are going to print it, println and v. And here, for example, say I will just get rid of this, and here we will simply call display something, and if we pass Neeraj, if we run our program again, so we are getting the output. But what will happen if we try to pass a integer? So our program won't compile, and already we are getting a compile time error, and even though if we try to forcefully compile it, so we are getting an error. Reason being that this function is expecting a value of type string, but here we are passing it as a integer, so that is why it is not valid. But if we change this function signature to accept an interface type, so that means, so this is pretty valid. And if we try to run our program again, so we are going to, our program is not going to crash, and we are getting the output. Reason being that whatever that every type, so see, try to understand it. Here with this integer value, we are passing an integer, and in the function signature we have defined that this function is going to accept a type of interface. So every interface, so this is going to be so see, this is an empty interface, and every type automatically implicitly implements an empty interface. So that is why our program didn't crash. And integer also that implements a empty interface, a string also implements a empty interface, and just anything. So not only concrete type, rather we can pass our custom types as well. So remember, so we created a manager struct, and here we created an instance of that manager struct, and we can pass it here. That is pretty valid, and you will be surprised that here we are getting a very correctly. So this is a very nice concept, so that if you don't know like what would be the underlying data type, and actually this kind of thing would be more useful when like in writing or working with APIs. So while we work with web development, so when in those scenarios, this concept would be much more beneficial, much more useful. So okay, so if we try to even if we try to print the type of this variable, so let us say %t, and for values we will say %v, and we will pass the v, and again variable v. So if we try to run our program here again, okay, so let me add a /n for a new line character. So here we are getting the type would be the main.manager, because the manager we have passed actually the manager struct, and this manager struct was defined inside the main package, and the value was because this manager struct was having only one struct field named name. Okay, so also let us try to call this function multiple times with different set of values. So let's say first time we passed as a string, second time we passed as a integer, third time we passed as, let's say, 50.62, and also, so let's say a boolean, and like this. So let us try to run our program. So our program didn't crash for the first time, so we are getting a string, second time integer, third time float 64, bool, and a main.manager. So this is how like using the we can use the interface as a type as well, in order to make our program or our application code more robust to accept just anything. Okay, so that's all for this session, and if you have anything to say, any doubt or any query, so please do let me know in the comment section, so that I will try my level best to answer them as soon as possible. And in next session, so we will see about type assertions. So so that we can make the most of this whole concept, interface as a type. Okay, so stay tuned, and I'll see you in the next session. So till then, take care and happy coding.